All right, guys. Today we're gonna talk about central angles and inscribed angles. So central are called central angles because the vertex of the angle is on the center point of the circle. So notice here the vertex is A is the center of the circle. So CAD would be considered a central angle because the vertex A is on the center point. Notice the sides. AD is a radius and AC is a radius. So it's made by radii. And the only thing we need to, I always teach it as central are the same. Central are the same. And what that means is the measure of the central angle, CAD, is the same as the measure of arc CD. So let's say this angle was 80 degrees. Then the measure of arc CD would also be 80 degrees. So central, same. So when you're looking at the examples, you know that central, right? ABC is a central angle, has to equal 96. So 3x has to equal 96. So x equals 32. Divide both sides by 3. All right. Here, you know 6x plus 6 has to equal 114. Central, same. Subtract 6 from both sides. And then divide by 6. So we get 6 into 10 goes once. 18. All right, so that was central angles. So central, whatever the angle is, the arc is the same. And then we have, then we have inscribed angles. Inscribed angles, I like to call this Pac-Man. Because it kind of looks like a Pac-Man mouth to me, if you think about like Pac-Man. There. Kind of looks like a Pac-Man to me, but I always call this the Pac-Man theorem. So notice where the vertex is located. It's located on the circle. So CAD, notice the vertex is on the circle. This would be considered an inscribed angle. It's made by two chords, so AC is a chord, AD is a chord. So what's the theorem? All right, so I always say Pac-Man is a messy eater, so only half makes it in his mouth. So let's say that CD, this arc, is 100 degrees. This angle, CAD, is only going to be half of that, 50. All right, so Pac-Man's a messy eater, only half makes it in. So if we look here, this is 120, only 60 is going to make it in. So we know 4x has to equal 60 because it's an inscribed angle. The vertex is on the circle. Divide by 4 and you get 15. All right. Here you're kind of going the opposite way, right? 63 made it in, so out here had to be double that, 126. So we know 5x minus 4 has to equal 126. Add 4 to both sides and divide both sides by 5. So we get 5 goes into 13 twice with 3 left over, 26. All right, so that was central and inscribed angles. All right, so we're going to do a couple more examples. That's a little crooked. Let's rotate this. There we go. We're going to do a couple more examples just to kind of do some basics here. So you look at the angle, right? We know that's central because it's on the center. Central, we think same. So x equals 40 degrees. So we like central angles. Here, vertex is on the circle. That's your Pac-Man. But notice we don't see the arc that he's eating. So you've got to actually use other stuff to get there. I will tell you, you might use diameters. You might use the total circle. So in this one, total circle is 360. Well, we already used 260, right? So we're going to say 360 minus 260 leaves me with 100. So we know that this arc is 100, because again, all the way around the circle has to be 360. And now we can say Pac-Man's a messy eater, half's going to make it in. So we took that 100 and we cut it in half. See all this lovely work? I want to see your work. Obviously here we didn't have to show much work. But for the most part you can show me something. Here again I see central, right? So if this is 20, this is 20. Now I also see a diameter. So you know a diameter cuts a circle in half. So you know that this is 180 degrees. So we can say 180 minus the 20 we already used, and we're left with 160 degrees. And that would also be this angle in here. Here we have 90. So understand, here's your Pac-Man. Again, it's on the circle. Here's your Pac-Man. Right, half made it in, so outside had to be 180 for 90 to make it in. Same thing here. Here's another Pac-Man going this way. Here's 50. Here's a Pac-Man. 50 made it in. 100 had to be out here for 50 to make it in. So you can do 360 minus those. So 360 minus 180 and 100 makes 280. Leaves you with 80. Or you could have said a triangle is 180 degrees. Minus 90 minus 50, you're left with 40. And then again, 40 made it in, so 80 had to be out here. So you could have done it multiple ways. And there are multiple ways to do these problems. And the last example, so let's see what we got going on here. We need to find the measure of arc, BAE. BAE is all of that. So we want the measure of that arc. Well, let's see. I've got everything else. So I know a total circle is 360. Minus, what is this, 50 and 40 makes 90. 115. So 360 minus 115 gives me 245. And that would be this remaining arc. They could have also asked me what's the measure of angle. Oh, I didn't put a letter here. How about we put A, B, C, D, E. How about we put an F here? So if they ask me the angle BFE, right? BFE would also be 245. So I just want you to see how they can kind of phrase the same question different ways. They could ask you for that central angle, or they could ask you for the arc. The arc and the central angle are the same measure. Central, same. So when you get to your worksheet, the first part is just, you know, working, again, read. See if you're dealing with Inscribed or Central. I will tell you the first page is Inscribed. The second page is Central. And then see what you're working with. Okay, you might see a diameter and think 180, right? You know, this is all 180. You might see vertical angles and know they're equal. You might see little rainbows in here, which means if this is negative 27x minus 3, then this is negative 27x minus 3. And you know a complete circle is 360. They should all add up to 360. So you're going to use a lot of different stuff here. But yeah, go ahead, show all your work, get that done, and that's it for today.